Welcome, welcome, welcome. I'm Blades. Oh, where are we up to now? Number 8, eh? C++ command design pattern. Let's explore. Well, I did choose a hard one. Let's do it, and let's not mess it up, Blades. Come on. So far we have a server. Now the command design pattern revolves around a central point and a central idea, and that is to split one side from the other. So the client and whatever you are working on are split completely, and they are split by something called an interface. So there is an interface between the client and the server, and that's how it's going to look. The client is going to be main. This is going to be our client, and our server is going to be somewhere buried in here. Networks module 2. Here we go. Let's do a folder, a new folder, and we'll call it interface. How about that? That's hard. There we go. We'll call it interface. In interface, we are going to have a header file, and we're going to actually do our first class. Wow. Interface. Let's call it interface command. .h. There we go. Interface command .h. Ta-da! There it is. Hash paragma or once. It's going to be in the namespace of module 2. Nothing new there. So you've seen all that before. Difference with this one is we're going to have a class, but I want everything to be public, so there's no point in calling it a class. We may as well just call it a struct, because the difference between a class and a struct is that a class is private. Everything in it is private unless you decide otherwise. In a struct, everything within it is public unless you decide otherwise. This is going to be a massive struct full of interface, so it's interface command. That's right, isn't it? Interface command, yeah. So it's this massive struct here, semicolon at the end, to make sure it knows when the end of our class struct is. And the first thing I'm going to write is going to be the word virtual. This means nothing. It doesn't exist. And that's going to be our destructor. So we're going to not have a destructor. Yeah. Well, we're going to have a virtual destructor. What does virtual mean? It means it can be overridden by any class that uses the interface command as its base class. That's what that means. And we'll also have the method of the interface itself, which will be virtual, of course, because everything in this struct is going to be virtual no matter what we do. And that's going to be void, and we'll call it execute, because we can. Execute, there we go. We'll make it equal to 0 as a, because it's void, it's nothing. It ain't nothing. So it doesn't execute anything itself. So there's no body, there's no nothing to it. It's just execute. It's a function which can be overridden and used. And that's our interface. Okay, so if that's our interface, what are the commands? Well, let's find out, shall we? So, interface. Done. Really? Yeah. Where is it? Come here. Come here, come here, come here. New folder. We will have commands. It's plural, but I'm only putting one in. Because I said I was doing it simply. Let's see, which command shall we have first? New file. Yeah, we did it all in a header file. That's a full class in a header file, and it does nothing at all. It just sets things up for another class, really. So we can get rid of that. It looks completely weird, completely silly at this point in time. Doesn't make sense. That's good. If it did make sense, I would be worried. In commands, we shall do a command, new file. And it's going to be server on command. How about that? Good enough? Yeah, we alright with that? Server on. Bit more to this one, unfortunately. Hash pragma once. We'll need a couple of includes, and we'll need the interface, and darn it, we can't write this. We haven't got a server. We can't switch a server on unless we've got a server. Okay, we've got the server there. Let's see what other servers I can have. Okay, let's have a TCP server. I know what TCP server looks like. That's a TCP server. Okay. Transmission Communications Protocol server. Safe handshaking, safe deliveries, handshaking and stuff like that all goes on within there. It's quite a nice thing, but we're going to write a test one as well. So I can't write this. So under server, new file, TCP server. There we go. TCP server .h. And just want to put it in a header file for now. It does become a full class in its own right later on. So hash pragma once. I'd forgotten you have to do this first, but there you go. And this can include our favourite C library, which is std standard input output dot header file from C. We'll namespace it. Module 2. Nothing surprising there. And we'll make a class. It's not going to have a CPP file because of what it doesn't do a lot at this stage. So we'll just make this a simple class, a test class, again, for TCP server. There we go. Everything's private, isn't it? So we'll just do the public bits, or a couple of public bits. We will have we'll have void. No, we won't. We'll have public. Yeah, I always backspace here down to public. Yeah, let's do it that way. Public colon, and then we're just going to have void turn server on. There we go. It's a function which will turn our server on. As you can see, it's now turning our server on. There we go. \n. That was complicated, wasn't it? We know how to turn a server on. I mean, don't we have a server here somewhere? Why have I got two all of a sudden? Oh, that's test server, sorry. That's how you turn up to line 26 is how you turn a server on. No, up to line 19 is how you 17 is how you turn a server on. That's how you turn a server on there. That bit. That's how you run a server up to that bit, and that's how you close a server. So, right, what we're going to do with our TCP server? Well, we're going to turn it on, yeah, alright. What else can we do with it? How about turn server off? We'll pop that one in as well whilst we're here. And that's just going to be printf. Let's see. Server has shut down. Full stop, \n for return carriage. Lovely. As you can see, it's a massive class. It does a lot of things. It turns the server on and it turns the server off. That's all it's going to do for now. For the testing, I think that's enough. So we've got our TCP server. So hopefully now we can do the command to turn the server on. And for that, we are going to hash include. And it's quotes. So it's up one level. And it's going to go across to our interface. There we go, and that will be interface command. Good, it recognizes it. That's very handy. We'll also include // So it's nicely picking it up now. TCP server, please. There we go. I like this. Namespace to protect it in module with the name of module 2. It's just protection really to stop things getting mixed up. Nothing else in the standard library is called module 2, I don't believe. So we should be quite alright with that. So server on, it's going to be a class. Yeah, a class, just to turn the server on. Wow. We'll call it server on. And we are going to couple that and inherit public interface command. There you go, it came up for us. That's our class. So we're actually doing inheritance now. I think you've seen me do inheritance before. Especially with like Qt classes and stuff like that. I usually try and avoid it. I'm not a big fan of inheritance, but when it's a pure virtual function like interface command is, what it does is it sets up our class. So we have to do the execute. We have to override the execute. And the way to do that is we have to do it publicly as well. That's interesting. Public, not thought about that before. Void, no. Just have space a minute. Void, because we're going to have something else. Execute, which is from interface command, if you remember. And what we want to do is we want to execute something. And it will be our m_server. And it's going to be arrow. And it's going to be turn server on. Because that's what we called it, isn't it? That function. But we don't have an M server. Yes, we do. Because we've just included it. TCP server, we just included it. So we can now have an M server. Now to make things proper, we should really set that. So the best idea is to do a constructor, I think. So we'll do a constructor and we'll call it server on. This is the constructor. And all that's going to do is take a TCP server, star server. You've seen me do this a million times. I usually use a colon, don't I? Yeah, I'll do the same again. So it's colon, and then it's m underscore server equals server, and that's it really, isn't it? Yeah, couple of braces, and that's it. Yeah. So that's me constructor, and the application does one thing: it executes turn server on, which is the command server on turns the server on. There you go. And we have to just check through that we've done that correctly by looking at the TCP server here. You'll see it's turn server on command. Turn server on command. Server is now on. There you go. So you can see how by using this interface we now have this structure which is automatically being built for us, and that becomes very important when we come to the next part, because that's how you turn a server on. Well, that sounds obvious, doesn't it really? Yeah, but what have we forgotten? We've got a command and we've got an interface, but we have no we need a manager. We need a manager. Yeah, I mean, this is awful. I hate managers normally, but yeah, let's have one. Networks module 2. Come here. Come here, you little monster. Let's have a new folder and let's call it manager, shall we? Yeah. For our network manager. What we're going to call this one? We are going to have a new file. It's going to be command manager. How about that? Should be really network manager, I suppose. But no, it's the command manager. And that will be .h. And under manager, we'll have a new file, and it will be command manager.cpp. Ooh. What's going on here, Blades? You're actually doing a CPP file? Yeah. I thought I would on this one. So let's have a look at the CPP file first. And that is hash include. Get out of that screen, get into this one. Hash include. I'm still on line 1, aren't I? Don't do it on line 1, do it on line 2. And it's going to be command manager.h. Thank you. And then it's just going to be a namespace of module 2 with some curly brackets. Magic. Fantastic. Just copy that over and save that out. So this is hash pragma once. Might need some includes here, I don't know. There we go, just paste that down. Okay, let's have a look at this header file. We have got a couple of includes. We're going to need a vector. It's a storage class given by the standard library, which gives us an array or a list which has no end, rather than a list where we define how many members it has. This one is just a growable one, and you'll see why. We also are going to include / interface again. Because remember, we're going to always... why has it stopped picking up? Because I haven't done it right. That's why. Hash include / and I want interface. Second one down, slash interface command. There we go. That's nicely done. And the class, this course, is going to be command manager. That's pretty obvious. I think you could work that one out. There we go. That's our class. Now, what do we want to do in here? We will need a vector. So that's std : vector. What are we going to put in our vector? We are going to put in our vector. This is going to go absolutely through the roof on sensibilities. We're going to put the interface command in there. And we're going to asterisk it. So I just want somewhere in memory an interface command stored, and this is going to hold all of our commands. So now I can put in a plural and get away with it. So that's going to add we're going to add all of our commands into that vector. That is going to hold everything. Okay. What do we want public? Quite a lot, actually. For once, we're going to do is a constructor. I'm going to do it properly. Command manager, blah blah. Do that properly. We'll do a proper destructor because we need it. Because we've got an asterisk here, we need a destructor. That's how you know when to use a destructor and when not to. Command manager. That's that one done. Let's have void. And we're going to need to add commands, aren't we? So insert new command. How's about that? That's a good long one. Does that need anything? Yeah, it needs a command. So it's interface. Sorry, interface command. I should have just called it interface, shouldn't I? Silly me. I'll call it command. There we go. I think that's pretty obvious what that function does. And then we are going to have, because it's the command manager, this is going to be our main entry point to all the commands. So to initialize or send a command, we are going to use void, and we'll call it server command. And this will take int command ID, because we'll need a command ID, trust me. Why does that keep going squiggly red? What's wrong with it? It's that there. I'm glad I noticed that. That's why we need IDEs and these kind of this is actually quite a good what's it called now? Not word processor. Editor. Text editor. This is a very good text editor. It comes up nicely with the errors, and in Microsoft's defense, it's not like Visual Studio. It doesn't break down halfway through. And if it does, it's easy to start and stop this one, where Visual Studio can take a while to reload up. So it's, so it's not as bad. I'm going to add an extra function, which I don't really think is needed, but it's to prove a point. And what we're going to do is, to prove the point that the command manager is in command, we're going to have here void process. Oh god, I'm going to really naff me. Process, that's it. Process command. Naffing me head up here. There's one C in it, yeah. And again, it's just going to be interface command, and it's just going to be star command. Okay. That's it. That's all we're going to need, I think, for a command manager. So we can insert new commands and we can issue commands. That's all we need. That's all we need to be able to do. We don't need to be. We don't want to do anything else as being us. So where do we start? We start from public as usual, and we copy everything down to the void. Copy. And whilst we're out at it, can we just save that out, please? Control S. Yep, that's done. So that's our header file. This is, oh God, this brings back memories of doing this. So V. Let's have a look at how much of a mess it's made. Right, okay. That's fine. So public, we can get rid of. We know that. That gets replaced with that. And we'll just call it private. There we go. That's just a reminder for me when I'm looking at it. First thing we need to do, copy and paste. We have to make it all everything has to be a member of command. We'll do that first, just before the insert there, and just before the S. There we go. And just before the P. There we go. And let's put them all as functions. And there we go. Just making up some functions now. Take the semicolon off and put your braces on. Braces in. Sounds weird, but yeah. I'm not sure if that was a sentence I really meant to say. And the last one is that one. And there we go. All done. We're a bit far out. Shift. Is it Alt on this one? Yeah, it's Alt on this one. See, it's going to make a mess of all the spacing, but I don't care. There we go, and we can get rid of line 29, it's not needed. Because I know that it's not needed. There we are, we have our CPP set up. Here we go, what have we got? Command Manager include, yep. Module 2, yep, check. This one's obvious. That's what I always put when I don't want anything else to do. On destruction, we have to get rid of the star, as I mentioned, because that's memory that's outside of the class. That's in main memory or well away in your machine somewhere, wherever the system has decided to put it. That's system memory. They call it the heap. Yeah, system memory, heap, H-E-A-P. Yeah, I think that's what they call it, but I don't say that. I'll call it system memory because that's how I remember it. So we need to free that up, otherwise it won't get freed up. So let's free up our memory. So it's going to be an unsigned int I index. I said I wasn't going to do I anymore, didn't I? Index equals 0. In other words, from the start to index, as long as index is less than m underscore commands dot size, however many commands there are, semicolon, and then we just go through them, index plus plus. So we just increment index by 1 each time we go through the for loop. And what we're going to do, we could put brackets in, but it's only one command, so I'm not going to. It's delete. We're just going to delete m underscore commands, and that's going to be index. Lovely. That works out nicely, doesn't it? It's so simple. If you've noticed, everything is small functions. There's no large functions going on. Everything's broken down into these smaller things. So to insert a command, all we do is we take our commands and we do a dot pushback, because it's not a star itself. Pushback, and we are going to push back whatever command we've been given. There we go. So it came through as an asterisk, remember? I put that asterisk in there. So what happens is that command is pushed to the back of our list, or queue, or whatever you want to call it. That command is pushed to the back and joins our list in between these pointy thingies and makes a list coming down like that. Yeah, okay. And M commands gives us a location, or points to the location in system memory where it is. That's what that is. That is actually a pointer. Well, it isn't a pointer, it's a memory address location anyway. Gives the address. Right, that was that. We've inserted a new command. That was easy enough. Let's issue a command. This is a bit trickier for me because we have to really create a new one. So interface command, I'm just going to call it C. And this is just an abbreviation because there's no real point. It's not going outside of this class. Star C just gets destroyed at the end here where it's got the red squiggly. That's where star C dies because it's been brought in here. It's not M underscore star C. Sorry, star M underscore C. So it dies here, which is good. After it's been used by M underscore commands. Is that right? Yeah. And it's going to be command ID. I don't know which one it's going to be. Whatever command you asked for. No idea what it is. Can you see what I mean? It's all disconnected. So I've got no idea what the command is. Neither is the command manager. The command manager doesn't care what the command is. All it's going to do now is say process command C. Now, I could have done process command C inside of this function, but I wanted to actually keep the processing private so nobody else can do this by accident. Nobody else can just suddenly wander in here and try and use our command, because it's a private function. First of all, they would have to generate a new class, they'd have to generate a new command structure, so they can't use our commands that we have generated. It just makes it a bit less hackable, should you say. So all we're going to do is take our command and watch what happens here. This is absolutely hilarious. Remember how I said we had that void, that virtual thing? Well, that virtual thing gives us that. That's how the virtual thing comes through the inheritance system. So we can now take the first one of those and execute. Yeah, and that's it. That's how you process a command. As I said, I could have put that there, but I feel safer that we process the command in private, not in public. Personal thing only, your choice, I don't mind. That's it, that's your class. Right, so I've got a command class. It's still, you're still not putting it together in your head, but that is the key. That is the one that will fail every time. That's the one that gives you the error every time, because we forget about the virtual. And I can't even remember now whether we need override in it, because we've got a destructor as well. Maybe we should. Let's just go and have a look and see if it'll work if I put an override in. So it's the interface. No. Here it is. Yeah, what I would do is I would put override there. I'm not sure if I should. I'm starting to get red squigglies. expected a semicolon. Yeah. I would have thought so as well. So no, I'm not going to put it in. But that's what it's doing. In essence, yeah, our destructor for server on is automatically created by the compiler, and that is the override for the destructor, and that allows us to destroy our virtual class at the same time. When this dies, our virtual class interface command dies as well. So that gets a knock-on effect. You've seen me probably in the past put like class created and class destroyed prints in all of these kind of things in the past, but I'm not going to do it this time. So let's keep that down, and that down. Server down, please. I need to look in there, and we need to do our profile. So, Networks Module 2. I will do CPP first because it's easiest, and the only one that we've added is Command Manager. Fair enough. At this point in time. It's pretty obvious that that's going to have a CPP eventually. So it is Networks. Networks Module 2. It is Command Manager. Command or Manager. Manager. And it's Command Manager.cpp. There we go. And get off me. That, please. So that's that one done. Here we can start at the top. Source, forward. It's Networks. And the top one is Commands. Is it? Yeah. Networks, Module 2, Commands. Yep, okay. Commands. We only have one command, and that is server on.h. Put a dash, and then it's source. Next one, please. Network module. It's not commands now, is it? I've only done one of those. Interface. And that is that horrible interface command. .h. Nice. And then it's manager. In Networks. Manager. And this is Command Manager, isn't it? .h. Next one will be server. Source. /network /server and / did not have a test server put in already. No, I didn't put the test server in, did I? I think we should do now. Yeah, well, TCP. Well, no, I don't think we could do. Don't have to. TCP server.h. Yeah, go on. Source. Networks. Did we put module 2 in? Yes, we did. Good. Networks module 2, and that's server. And now we have test server as well, don't we? Our proof of concept is there. So that was the only one I forgot from last time. Glad I did, because now it's in the right place. Let's see, anything else I've forgotten? Nah, I'm not really bothered if I have, unless I want to use it. So that's a lot of additional files. But as you can see, for each command, we're going to have a new file. So you want to be be aware of how many commands you've got. I would say if it starts going over, say, 10 or 20, you want to start thinking, is there a better way of doing this many commands? Can you do command groups, for instance, or something like that? And instead of having one command manager, have command groups. You're going to have that anyway, because you're going to have user commands, then you may have advisor commands, and then you would have administrator commands. So you've got 3 types of command levels already, and I haven't even addressed that. But that's to think about. That's to think about. So we've got everything in here. Our CPPs are growing like mad. Let's hope that works. Well, shall we find out? I think we should. What can we do to find out? Let's make a command design. Oh, am I being cheeky about the words here? Yeah. What are we going to do? We're going to put this in module 2. Okay, let's do this properly. So, starting at the top, let's title it the command design, our grand design pattern. There you go. Oh, mental. And let's hash include, let's hope this works, source, forward, net, works, yes, we're doing well, and we'll need our commands. And what commands have we got? Server on.h, there you go, that's it. Right, hash include. Every time you have a new command, you're going to have to add it here as well. Don't like that. I think we'll do something about that. So we might have a known commands here. User commands, that's it. Yeah, we'll have that there. I'll tell you how it's done. Yeah, we'll do that in a minute. SOURCE, and it's networks module 2. We've run out of commands, so let's do the manager. We don't need the interface, I don't think, because that's void. Command manager. And what else do we need? I think we better have the server. So source. Networks, and yeah, server. And we'll have the TCP server. We'll have that one. Yeah, okay. So let's namespace this up and do it. We'll put it inside module 2. For now. Because we can. And we'll call it void command design. There you go, that's a good title for it, isn't it? So, what do we do first? Well, what is the object of all of this? The objective of all of this is to have a server. So let's make one. So, construct a server, TCP server, a TCP server. There we go, full stop. So we know how to do that. It's just TCP server star. We'll call it server. Why not? It's just it's a function, this, not a class, so it's no m_star server available here. We'll just do a new TCP. We'll put it out in system memory server, and we'll just have the brackets. That's it. There we go. We've now constructed a server. Now we need to define our commands. So let us define the commands. All of the server commands, because that's what it's all about, this, really. So let's choose server on, because we've got that. There we go, server on. We've got it already. We're going to call it, what words can we use? Turn server on. Yeah, that'll do. And that's going to equal a new server on. But doesn't server on take a parameter? Yes, it does. It takes a TCP server. Oh, we've got one of those. So let's, and it does it, yeah, it's an asterisk, isn't it? So it's server. There we go. We'll just pop that in there. And that means that is now, that turn server on is now tied to our server and the function server on. Yes. So we've tied the two together. We can now do something rather silly. We can use an enumerator. And enumerators are a way of naming integers. And it automatically does it for you. If you give it a word, it'll start at 0 and work its way up. 0, 1, 2, 3, 4, 5. It'll just count up. So we will enumerate our commands. And this is the fun part. And we will say that server on is the first one, and we want the first one to start at 0. How's about that? Semicolon there. Lovely. So we've enumerated our command to 0. Server on will turn server on, we hope. Are we okay with enumerators? You'll see better as we add commands, I think. It really doesn't make too much sense with one command to do that. So we better set up the manager now, otherwise it'll complain at us. So now what we need to do is construct the command manager. Yeah, we can do that, can't we? So to construct the command manager, all we're going to do is ask our command manager, very politely, it's the second one down, command manager, what we're going to call it? Server manager? Because that's what it is, really. Equals a new command manager. Second one down. Does it need anything? No, it doesn't take any operators, does it? No, it doesn't. Fair enough. There we go. And what we need to do now is take our server manager and tell it the command. Might help. Server manager, would you please insert a new command, and it's going to be turn on server, or turn server on. God, how did we do that wrong? Turn server on. There we go. That command is there. So that goes there. Okay. Whatever you've put there goes there. You can call it whatever you want. I'm just trying to make it look sensible. So there we go. Server manager, insert new command, done. And now what we can do, just make a bit, yeah, we can now do what? We can now do a server manager. Hey, server manager, remember that command? Well, I think he does. That command, could you do it for us? It's server on. Or 0. It's the first to go into a vector. At vector position 0 is where it was placed. It was inserted first, so that one has to match that. So that is the 0th enum. Okay. So if we add another command, it's going to be the first enum or the 1th enum. You'll see. You'll see. So that's it. So now we do stuff and finish. This is why I haven't put a full server in, because we haven't got stuff to do yet. Do stuff. Right. Okay. Let's put the semicolon at the end of that, would help. Anything else missed out here? No. That is a comma, but we haven't got another value, so we don't put a comma after the last one. Right. So that's separated by commas, because there's the semicolon. Right, I'm all happy with that. So how do we use it? Well, we just set it off and let it do it itself, I think. Because we've got system pause here, we can do that. So what I'm just going to do here is module 2, colon, and we have all of this stuff, and I want the only function in it. Command manager is a type, server on is a type or class, TCP server is a type or class, you can see the symbols for it, and interface is a virtual structure, and that's why it's got that thing by it. The little square box means that's our function, so I can call our function like that. That's it. Doesn't take any parameters. No, it's just a straightforward function. I could have written all of this at line 50 down here. I didn't need to write it up here, but this is my development area, and it keeps all the includes together with my development, as you've seen prior. Okay, that's how we would use it. Let's see if it works first before I go any further, because I bet it doesn't. I am not going to use the terminal as normal. I'm going to go into the terminal so I can read everything. CD server, and I'm just going to CD explore. Stupid me, I've been talking about servers, haven't I? And we're in C++, aren't we? Damn. There we go. Yeah, we can build here. Okay, what have we done wrong here? Error 2. Expected semicolon after class definition. Server on, line 6. Server on line 6 has got nothing to do with that. I think it's to do with this lot here. And there's no semicolon on that. Get out of it. I don't like that. It's not really explaining what it's doing, so let's do it the other way. Let's do it that way. So we can take you lot out, and in here we just put m_server equals server. That's an easy way of doing it, and it's not going to complain at us. It's not going to get confused, because that's a simpler way of looking at it. Okay, that's server on. Anything else it lost? Doesn't look like it. In file from C++11. File from C++11. Okay, just close that. Yeah, fine. That's okay. That's okay. Let's deal with you again. And build. Oh. After class definition. We've got a... So let's follow it through. C++, CPP 11. Okay, C++, that one, 11. Hash includes source networks command server on.h. And that is server on.h. Calls those two, that's fine. Namespace module class server on colon. Ah. Should we put interface command there? It's got no constructor now. It's expecting a semicolon. I can't see it, I'm sorry. After class definition. Okay. Make clean. I don't see it there. But it persists. Where did my clean start? Why is it not showing the clean? No idea. Ah, there it is. Make clean. So, make clean is there. Then we build. Failure to find source. Ah, that's better. Module 2 manager command manager.cpp. Okay. That's because there's two N's in it. Duh. And I've probably spelt it right everywhere else. Rename. That's probably what's messing everything up. There we go. That might help. So you're done. Okay. Make sure it's in. Oh no, it would be. Yeah. Clean. Just cleaning it so that I don't get me make files all messed up. Build. And it still doesn't like that line. Clean, cleaned, build. The system cannot find the path specified. Yep, that's right. I know what that one is. QMake, yep. Program, explore, call. Debug, yep, that's right. Entering directory, correct. G++. DLL export, yep. Okay. Include, yep. In a file included from C++11 source, it's saying after that. Oh, have I done that silly thing again? Have I done that silly thing again? It's telling me the error's in here, and that's gone red. I have. I've done that silly thing again. I've made a class, and I haven't put the semicolon at the end. So, yeah, it was telling me the truth. Clever build system. Clever. Okay, that's it. So if I now run debug, what's it called in this one? C++. Debug. Yeah, C++. That'll do. In the wrong side of the screen again. There you go. Server is now on. So it worked. But we can't leave the server on. We must be able to switch it off. Oh, come on. Didn't you see that one come in? So how are we going to do that? Oh, press any key to continue, right, okay. Bloop. So, first of all, we want to turn the server off. So ignore debug. And so in the server, we already have turn server off. I put it in there on purpose to say, hey look, I want to introduce this command. What do we have to do? Well, if we go up here, we don't have to do anything. We go and look in there. We don't have to do anything. Oh, if we look in here, we don't have to do anything. Hold on a minute. In commands, we can't add it to that, so we would have to make a new file and call it server off. .h. Now, what's that going to look like? Well, we've already done server on. We messed it up the first time, so let's copy it so we don't mess it up the second time. Copy to server off. Okay, the only difference between the two things is the word on. It goes to off. So it's still an M server, server off. See, it comes up here. Turn server off. And that's it. So we make a command called server off. We then save it. We know it's done correctly because we have a template. We have the template of server on to do that for, well, to help us do that, shall I say. So we've now got server on, server off, two different files. Okay. And what else do we need to modify? There isn't anything, is there? No. All we have to do now is use it. So we've added a command. It's in the commands and it's on our server. So the only thing that has to match up here is our commands here. Interface is no good to us, the manager's no good to us. So TCP server has to have them, and our commands has to have them. Is that it? Yeah. So those are the only two things. We have to have a command for each. Now, as said, I didn't like that, so I'm going to have an extra command in here. And it's going to be a new file, and it's going to be called user. No, this one's going to be called admin underscore commands. And that's going to be a .h. I'm doing that on purpose, and this is going to be pragma once, and it's just going to be hash include anything that is an administrator's command. So we want server on, obviously. Trying to get this right. All the administrator commands come in here. Include that, and that's now server off. There we go, just put an extra line in to be helpful. So now I've got administrator commands. That's better, because they are really. Go back to our CPP, and instead of doing that, we're going to put administrator commands. Admin underscore commands. So we now have a list of admin commands, server on and off. And what we're going to now do is call this admin, aren't we? Server on Goes in there, yeah, that's okay. Commands are now increased. So server off will increase the definitions. And we'll call that turn server off, because we can, equals a new server off. And that takes a server. Semicolon. So that's good. Then what we do here is we just put server underscore off. And we have to put a comma after each one, like that. Automatically, the compiler will set that to 1 for us. And as that is the 0th, what we need to do here is just put server manager. Server manager, and it's going to point to insert new command, and that's just going to be turn server off, which will go into position 1 on that vector. And of course, it'll be enumerated to 1 as server off. This is the 1th enum. So whatever we type on that line becomes that. If we want to remove a command or change a command, don't you see how easy it is? Yeah, so adding commands isn't that bad. So now we can do stuff, and now we can say server manager server command, and it's just going to be server off, because we've enumerated it to 1. So that's the 0th command, and that's the 1st command. 0th command and 1st command. 0th insert, 1st insert. Because computers count from 0. Nothing to get your head around really there, is there? So, if we run this program, what do we get? Server is now on. Server has shut down. Press any key to close. Done. That is your command design done, completed, with an option left open to go backwards, to cancel or undo. If you were doing a text processor, this is a good one for doing commands off here, and you had pull down menus like this. On here you'll see undo. Well, it's using this command design with undo. What it's got is a stack, and it's just putting each command that you use on a stack, and when you undo, it just goes back 1 and restores your whatever you're doing, your text editor or whatever, to the previous state. And that's how the undo command works. It actually works using this. The undo part comes as a command, funnily enough. Yeah. So in here you would have a user commands, and you would have undo.h. Yeah. On the interface wouldn't change. The manager would have some changes in it, as this would now have to have a stack, which is an include, and you would have an std stack of interface commands, and then you call that m underscore command stack or something, and you'd have to delete that one as well in the title, just the same way as you deleted this one. And then here, every time an insert command would be issued, here you would then add to the stack, and you would then have to have an unadd to the stack, or an undo method. So if the server command was undo, an undo method would then be done. Cute, huh? Very easy to understand once you've programmed it. And when you've got it programmed and working for the first time, it's very, very easy. Now, if you look this up and you want to know what some of these parts really are, let's just have a look at our CPP in a minute. Here we are. Construct the command manager. This online, if you look it up, would be the invoker. That helps you out if you look it up online. That is obviously the command controller. The interface that I've used is usually called iCommand for interface command. They just abbreviate it. I think I prefer command interface actually. I don't know, but they've put iCommand, so I've used interface command on the wiki I'm talking about. So that's how I worked it out. I just use the wikis. Simple. The wikis are actually quite straightforward for all of these. They're very nice and easy to get along with. You struggle the first time because it's trying to get the manager right. And as you could see, I was umming and ahhing still about putting an override in. You don't need to, is the answer. It does that for you. And there you go, that's it. What do we do in our next episode? Not a clue. I suppose we'll go to the moon next. Oh gosh, that's a good idea. Let's do that. No. Stay here. Stay on planet Earth. Or Ultima Online. Wherever you like. C++, are you finished? Yeah, we are. Totally. Save. Job's a good one. Nothing I don't want to hide. ++ command, yeah. So here we have, explore #8 : C++ command design pattern. In the next episode, I'm going to start putting that server into that command design pattern. That's pretty obvious. I mean, I didn't write it for the fun of it. I wrote it because I wanted to do it. So yeah, changes will add, and command design pattern has been done. And I'll send that to my server. So I'll catch you in the next episode. Take care. Explore and have fun.